Most electricians know there's a 125% rule for continuous loads. Most of them apply it wrong on the exam. And in the field, wrong means overheated conductors. Overheated conductors means fire risk. That's not a technicality. That's a callback you don't want. Here's what you're missing. A continuous load is any load where maximum current flows for 3 hours or more. That's the definition straight out of Article 100. Commercial lighting, HVAC equipment, sign circuits. Think about a parking lot lighting circuit running dusk to dawn. That's exactly why the code treats these loads differently. If it runs for 3 hours straight, it's continuous. That's the line. Now here's where most people get it wrong, and this is the thing the exam is built around. The 125% rule doesn't just apply to the conductor, it applies to the overcurrent device too. And there's one breaker size electricians choose here that looks right, but fails the calculation every time. NEC 210.19A 1. Branch circuit conductors must have an ampacity not less than the non-continuous load plus 125% of the continuous load. The conductor has to handle the heat of sustained current. That's why the multiplier exists. Sustained current generates sustained heat. The 125% is the buffer. NEC 210.20A. The overcurrent device gets the same treatment. Rated not less than the non-continuous load plus 125% of the continuous load. Both the conductor and the breaker, not one or the other, both. So why do candidates fail this question? Because the exam gives you a mixed load, some continuous, some not, and asks for the minimum rating. And most people take 125% of the total load. That's the trap. Here's the number. 16 amps continuous, 4 amps non-continuous. Add them together and you get 20. So most people size the breaker at 20 amps. That's the one that looks right. That's the one that fails. Because 125% applies to the continuous portion only. 16 times 1.25 is 20. Add the 4 non-continuous at 100%, minimum ampacity, 24 amps. The 20 amp breaker is undersized. The conductor running at continuous load will overheat. That's not a code violation on paper. That's a fire hazard in the wall. 3 things to lock in before you walk into that test room. 1. Continuous load means maximum current for 3 hours or more, Article 100. That definition is the starting point for every question on this topic. 2. Both the conductor and the overcurrent protection must be rated for the non-continuous load plus 125% of the continuous load. NEC 210.19A 1 and 210.20A. Both, not just the wire, not just the breaker. 3. The calculation is non-continuous plus 125% of continuous, not 125% of the total. That distinction is the answer on the exam and the difference in the field. If the Florida EC exam is on your schedule, subscribe. New code content every week.